Hi, welcome to this combined event between the BCS West Yorkshire and Computing at School. The title of this is VR and Visualizations in Engineering event, and we're very happy to have the speaker Nigel Higgins joining us from Airbus, who's going to talk today. He's going to be joined by Francesca and Ben Wardle, who are current graduate trainees at Airbus. Over to you, Nigel.
So, hi, thanks, Dan. So as I mentioned, my name is Nigel Higgins, and I currently work at Airbus. And joining me today is Dan and Francesca. I'll let them introduce themselves in a moment. Before we get underway, obviously, we'd like to sort of understand a little bit about the audience. So could we have a quick poll on exactly who you are? So we've got a poll to launch, and that's if you're a BCS member or a student or a teacher, just so we've got an understanding of who we've got in the audience. So if you could launch that, Dan.
I have. This poll is in progress.
Okay.
Nigel, I'll just give a couple more seconds people to go to do that, and then we'll show you the results. 90% have voted so far. Okay, so people will still arrive, but I'm going to close the poll now, Nigel, is that all right?
Okay, yeah.
Can you see the results?
Okay, yeah, I've got that. So we've got majority are BCS members. We've got a number of teachers and also some students. Okay, that's a good mix. So it means that we don't have to focus on one area. So a quick bit about myself. So we said my name's Nigel, and I work today as a design process architect at Airbus in the UK. That's a bit of a mouthful, and it probably doesn't mean much as a job title. But I can run through my career, and maybe that will sort of give you a bit of an idea on what I work on. So I joined what was British Aerospace 33 years ago as a technician apprenticeship. After 4 years, I finished my time. I then became a design technician, working in design as a designer, originally working on A340 aircraft. That's the original production series. I then, following that, moved on to conceptual design. So I was looking at essentially blank sheet designs for new aircraft. Typically on that, I was working on the FLA, which flies today as A400M. I then moved on to A3XX, which flies today as A380. That was some really interesting work, particularly on the landing gear support structure, which was my main involvement. I do have a patent on that area. I then moved on more to design automation. So this is sort of my first move towards a ICT type environment, and that was automating design processes to actually allow us to rapidly create engineering data. And that was using a program based on an application called Common Lisp. Some of the older ones of you may have heard about that. Some of you, it'd be a complete obscure language. And that was combined into a programming language called IDL. And that was essentially first level artificial intelligence. It was demand driven. And we had the concept of modifiable, quantifiable children. So we could change the structure of the code on the fly, depending on data inputs. From that, I moved on to essentially managing that team, and then moved on to managing mechanical CAD across the entire Airbus across Europe. That role got moved to Germany, and then I moved more into a technical role in my role today. And generally that can be very varied. So that could involve things from obsolescence to security. But one of my main activities is the visualization and virtual reality for our UK satellite, and we'll come on to that in a bit more detail later. I'm now going to hand on to Francesca, who can explain a little bit about herself and her role in Airbus.
Okay, hi, so I'm Francesca, so I'm a second year graduate, so I'm just coming off the scheme at the end of this year. So I've done a range of placements across Airbus in different areas to give me an understanding of Airbus and how it works, and sort of get us up to speed before we start into a proper sort of final role after Christmas. So Airbus is not just commercial aircraft, although that's the division that we're in. So we also have a mixture of civil and military aircraft, including helicopters. So some of you may know this is the Eurocopter, which is the majority of the UK emergency services, and defence and space, so A400M, some satellites, secure communication, amongst others. So our headquarters is in Toulouse in the south of France, but we've got many sites across Europe and the world, including several in the UK, which you can see on the screen. So if you go to the next slide, please. So obviously this has changed due to the current situation, but pre-COVID, an Airbus aircraft took off every around 2 seconds, but this is much reduced now, given the sort of restrictions on flight and travel. But we've got around 400 operators for our 17,000 aircraft, so we're a fairly large sort of manufacturer. So that's sort of a bit about Airbus in general, but I'll hand you on to Ben, who's going to talk about IM information management in particular.
So my name is Ben, thank you, Fran. I'm a graduate currently in my second year, so I'm halfway through my grad scheme at the moment. I was an intern as well for a year at Airbus for a little bit. I'm still going through the process of understanding the company, and I get to work in lots of different departments throughout, so it's still quite interesting. But generally, when people refer to information management in Airbus, they're normally referring to sort of the ICT department. It's called information management because the way the company works is they manage more than just the communication technology systems. They manage the vast amount of information that goes through the company. That could be anything from IT and equipment and support needs all the way through to the design technologies that we use to produce aircraft, including the manufacturing shop floors type of things. So within Airbus itself, there's over 56,000 employees, so there's a lot of support that they need, which thankfully we help with. And as you can see, that support sort of generates over 40,000 incidents per month, but we have to manage that and deal with those types of problems on a day-to-day basis. Next slide, please, Nigel. So within IM, or information management, we have a couple of key sort of areas within the UK. One of them is cybersecurity, and we all know that security in computing is important, just to keep our data safe and ensure we don't lose anything. Then we have our service integration teams, which, as it says here, are responsible for the IT service desk. So all of those incidents that need solving, these are the people that are going to help solve those issues. They're a very busy team all the time. Then we have our engineering application solutions. So these are the people that are there to support the designers of the aircraft in deploying and managing any application they need, or designing a new application should they think they need one. Then we have some of the more fun sort of side of things that I enjoy, which is connected objects, where these guys try to make an impact on how we work together. So that's looking at new technologies, new initiatives, anything that's coming out, just to sort of understand how we can work with that technology within our company. And then we have all of our shop floor solutions, which are used on the shop floor to help deliver our aircraft and build our aircraft. Without these guys, we probably won't get a lot built. And then we have our extended enterprise. So by extended enterprise, we're talking any supplier, customer, or contractor that we might use inside of Airbus that we want to pass information to or work with. We need to have some type of connection with them. And this is all managed through our extended enterprise. Everything IM does tries to drive digitalization, but anything we do has to add business value. If it's not adding value, chances are we're not going to do it. And then I think Nigel wanted to add something to the end of this one.
Yeah, I'll come on to that. Well, essentially, if we think about IM and IT, our industry has some interesting aspects. For example, our product lifecycle and certification requirements on data retention mean that we have data life of over 70 years, approaching 100 in some cases. If I was to hand you a 10 or 20-year-old computer file, the chances are, even if you could read the data, editing it would be a challenge. So you can start to appreciate some of the challenges we have. We're not alone in that aspect. These challenges are now becoming shared with other industries, including the building industry, where all the BIM data, as they call it, has to be maintained for the life of the building plus. Other aspects that we have, old systems, and updating these can be a challenge, even to find developers to modify those applications. COBOL is a great example of that. You may have seen in the press recently, we delivered the 10,000th A320 family aircraft. We never anticipated a production run that long. So a number of years ago, we had a major project to adapt all our IT systems to cope with a 5-digit serial number. Essentially, we had a millennium bug, for those of you old enough to remember that one. In a complex environment, we often have a situation that the life cycle of commercial software is shorter than the period we need to test and deploy it. So our roadmaps are managed very carefully. Our CAD systems are a very good example. Typically, the CAD vendors are releasing something every year. That would take us a lot longer than that to actually qualify our CAD systems to deploy to the end users. So we tend to be out of sync or not deploying every version. But those are topics for another session. Today, one of my responsibilities is virtual reality and visualization, and we're going to take a look at this. Normally, I would have demonstration either on site or invite you onto our site so we can have a play with VR. Obviously, in the current environment, we can't do that. We're going to try and do a presentation with some videos to show you what we can do. But a bit of luck, for those of you who are interested, soon we'll be able to have you back on site or come and visit you with some VR kit so you can have a go. It makes it a lot easier for me to explain, but also a lot easier for you to grasp the concepts. And also, when I'm presenting this, recognize it's a view of VR. What I'm presenting is generally why we use it on our site. If you went to other sites on Airbus or other companies, they'd have a different view on why they need VR and also how they use it. Let's come on to that a bit later. Also, if I could ask, if you've got any questions to ask, can you pop them in the Q&A panel? What we'll do is, if they're relevant at the time of the presentation, we'll interrupt and answer those and try and make sure we cover those as we go. Otherwise, we'll pick those up at the end. Instead, on the theme of questions, I'm going to kick off with a question for you. So why do we need VR? Now, if we think about it, as a technology, VR is a relatively new tool. And in the UK, we've been designing and building aircraft for over 100 years without it. And that's included the world's fastest and largest passenger aircraft with Concorde and the A380. So what I'm going to suggest is that VR hasn't always existed, but the problem it solves has. We just solved it in different ways. And that's the problem of just how to visualize something to enable people to make engineering decisions and judgments. Let's try and explain this. At this point, I'd normally enroll an A0 engineering drawing on drafting film. Obviously, I can't do that here. For a long time, and even sometimes today, designs would have been drawn manually on 2D sheets, around 1.5 meters wide, or A0. And this is a good example. This is actually a 2D CAD drawing, produced around 30 years ago by myself. So this is a rib installation drawing of an A340 aircraft, essentially using CAD as an electronic drawing board. And this item would have been scaled to fit on the sheet. And this is coming up to more modern times. We now design components as 3D objects in the CAD system as models rather than drawings. It's got a concept of 3D. And in between, we would have had where we would have had surface modeling, where essentially it's flat items with no substance between the faces. So this is a 3D model of a rib, and it's a type of virtual model. And the item here is shown as a wing rib, similar to one in the previous example. In our design and manufacturing, engineers need to be able to visualize this for a number of reasons. And that could be for training, to show someone how to do something, or how they intend to design something, or even discuss and share ideas or concept things or problems. Also to make this decision on manufacturing or design solutions, how we're going to design and make something, or even familiarization, letting someone see the components and play around with it without interrupting the manufacturing site. That could be a dangerous area, or understanding how we could modify something. A good example of that is recently there's a component on an A350 that had to be replaced, and obviously that component, once the wing's built, it may be difficult to get those components out. So by modeling in VR, we're able to show that component had to be cut in two to take it out of the aircraft, and the repair had to be a two-piece repair scheme. So that's the type of things that they'd be doing for repair. A link to that is accessibility. So can we get in there and actually build that into the aircraft, and also during the life of the aircraft, maintain the aircraft. And to a certain degree, there's publicity. For various reasons, we need to show people what we're doing. Let's focus on just one of those aspects, which is accessibility. So think about this CAD model. Could you get your hand in there and remove one of those pipes? It's actually quite difficult to grasp that as a concept. Even if I show you a picture of the real item, it may be difficult to understand. So this is a similar components to what you've already seen on the 2D and 3D CAD model. The items down the left and right hand side of the wing ribs. So we're going to run a poll now. How big do you think this space is? Okay, how are we doing on the voting? Okay, so we've got a fairly even spread, and that's what I would have expected. So I'm going to make life a little bit easier for you. I'm going to drop a person in now. So as you can see, I'm not tall, I'm 1.57 meters, but this is a very large space. So this is actually inside the wing of the A380 aircraft. As a passenger, you'd never see this area normally. It's full of fuel, and those two black pipes just to the left of me, those are actually fuel gauges, so measuring the amount of fuel in that wing tank, just like your car would have. So moving on to the next one. This is exactly the same aircraft and the same wing, just a little bit further outboards. So that's towards the wingtip. So let's run another poll. How big do you think this space is? Could I stand up in here? Okay, so no one's gone for the 2 meters because obviously outboard it's got smaller and a reasonable spread. So again, I'm going to help you by putting someone in there. So it's obviously a lot smaller space in here, even though some of the components look very similar. So one of the problems an engineer has is that he or she will relate to what is being seen to scale in front of them to the last physical objects they saw, as a mental reference. So it's a subconscious bias. I've shown that we have items that look very similar but a different size, even on the same aircraft. Now, when we think our engineers may be working on an A380 or an A320 aircraft, that exaggerates even more. Now, to put that in perspective, an A380 tailplane, so that's the bit of the back if you're not a geek like me, is about the same size as an A320 wing. An A320 aircraft can fit under an A380 wing. So you can see we've got a very large range of components. Okay, I think you get my point now, and hopefully you can understand why we need to visualize things. And some of you are probably wondering how you get inside an aircraft wing. It's not a pretty sight. We typically enter through manholes in the lower cover. Now this is confined space work and it requires special training and a medical to pass to actually be allowed to do that. There's a number of dangers, and that includes the oxygen levels, actually getting stuck. Ultimately, if you get stuck in an aircraft, there may be a need to cut you out. And once the wing has had fuel in it, tank entry becomes even more controlled. I'll come back to that point a bit later on. So keeping our focus on accessibility, different engineering departments design a wing so we can get into the various places to build and maintain it. Now, a wing is a fuel tank, so this will also include wearing any breathing apparatus or protective clothing needed once the wing has had fuel in it. This can be tricky on a CAD system, especially when you think about the CAD designer using a very small monitor, and consider the fact that a design workstation has a 3D CAD system, but only a 2D display system. I've already mentioned on the older days, we had a drawing board, but we still solved it. We just solved it with different tools. So what were those tools? So one of the tools would have been building a prototype or a mock-up. And this was typically in wood. So you hear the term wooden mock-up. Now these may come as a little bit of a surprise to anyone who's not from the aircraft industry. So this is a first example. So this is way before the time that we had any CAD systems, as a Bristol Brabazon wooden mock-up. As you can see, that's modelled in wood, full size. I'm sure many of you will recognise this famous aircraft as a partial wooden mock-up of the nose section. For those who don't recognise it, this is Concorde. This is a little bit more recent, as you can tell from the colour photograph. So this is a hydraulic spray of one of our Airbus aircraft. You can see the individual hydraulic components modelled in wood, including the two spherical objects at the lower end of the picture. This demonstrates the level of complexity that you may need to put into a physical mock-up. And finally, a wing mock-up. None of the pictures I could find of this mock-up do it justice. So this is an A330, A340 mock-up. It was a full-size wing that used to be based in Bristol until fairly recently, around 6 years ago. Part of it is now owned by the Aerospace Bristol Museum, although I've not seen it on public display yet. Every mechanical item on that wooden wing moves, as it would on the real aircraft. So for example, in the picture here, we've got the landing gear. That landing gear retracted and deployed just like the full-size aircraft. And the wooden wing was housed in its own building. So we've seen how we design and provide visualization without VR. So back to the question, why do we need VR? Our move towards VR has not only been driven by the ever-advancing technology and reducing costs of this technology, but by demands in the aerospace industry itself. Obviously, we've got the normal challenges of ever-increasing quality and performance whilst reducing our costs, but we also have some specific ones. We need to have our designs ready to fly much quicker. every aircraft program we have has had a shorter length of time from design to first flight. And related to this is the speed in which we need to reach production rates of new aircraft. That's particularly important for Airbus at the moment. We've got what we consider to be a complete product line. So any new aircraft will replace one of our existing products. So as soon as we launch a new product, the chances are our customers will stop buying those aircraft. So we need to get the other aircraft into the market as soon as possible. So it's really reducing those timescales. We're now talking in terms of months, whereas years ago we would have been talking decades to launch a new aircraft. So we just don't have the time to build wooden aircraft. On top of this, we're producing many more customizations for airlines. Just imagine if we had a wooden mock-up for every airline. We'd have many hangars for the wooden aircraft. If nothing else, it's a fire risk. And in the Airbus business model, we have engineers all around the world who may be remote from any actual physical aircraft. And COVID home working has exaggerated this even more, with lots of our engineers and staff working from offices at home. On the more positive side, the cost of technology is ever cheaper, but also the amount of data is multiplying. We now make references to digital twins rather than digital mock-up, where many different attributes beyond geometry are being modelled and stored within the need to view them. The bottom line is we need to be able to collaboratively visualize complex data beyond geometry much faster and at a lower cost than ever before, and without taking up much floor space. So that's why we need VR. I'm now going to show a typical VR suite. So this is the bit where I'd sooner be showing you the real thing. And if we come onto site, this is what we could show you, or we could come to you with some portable bits. And the video here has been taken with a panoramic camera. So viewing in this way heavily distorts it, but it allows me to try and show you as much as the room context as we can. So the number of key features I'll point out. Obviously, you may have already spotted we've got a large screen at the front. That's actually a stereoscopic projection. So it's a double image with active stereo. So to view that, you'd wear a pair of stereo glasses, and you see my colleague here will put on a pair of those when we start the video. It displays objects one-to-one relative to this pair of glasses, which is being tracked. So the whole room is tracked by an optical tracking system. So you can just make out the cameras in the corner of the ceiling. So there's actually 6 in total. And those are tracking the typical the reflective white spheres that you see on all the VR publicity. The accuracy of that in that room is around 0.3 millimeters, which is more accurate when you put a pair of glasses on the nose of your face. So it's projecting one-to-one relative to the viewpoint of this pair of glasses. So I'm just going to start the video. I'm wearing a head-mounted display and body trackers, so you can see those white spheres on me. So in the head-mounted display, I see the display as it would as if I was there looking down. So being body tracked, I can look down, I can see my arms and legs, and I'm moving around the wing. So my colleague here is watching me as the avatar on the main screen, while I'm seeing the view. So that's his view on the main screen, and I see my view in the head-mounted display. And it's that one-to-one track display, which is one of the key features of VR. What we're doing here is seeing if we can pick up an object and move it into a part of the wing to see if we can actually assemble it. That's a typical application of VR. So I'm now going to show some key functions that we do use in VR. Now, obviously at home, I have got a full VR suite, so I'm going to try and show you some videos that we prepared earlier. Now, normally this is the chance where you get to have a go at this. Like I said, hopefully soon we'll be able to offer that to you. So the capability I've got at home is based on an Oculus Revive. So rather than the 10-point body tracking that we'd normally have in a VR suite, we've got 3-point body tracking, and it's trying to configure the body based on those 3 points. So even with that, I think you'll see that this is actually quite impressive for what it's doing. So we're now in VR, and what you'll see when we play the videos, it will jump around a little bit. That's because obviously it's my view with a head-mounted display on, and as I move, it's going to move the view about. I've tried to stay as steady as possible. So first of all, let's meet our 2 avatars. So we've got a number of avatars that we can apply in here with various states of clothing or size, and we can take control of these either through body tracking or with the 3-point I've already said. And what we can do also is link any of our VR suites within Airbus together. So these avatars could be controlled by different people all around the world working in the same VR environment. And that's something we've been doing for a number of years now. It becomes a very powerful collaborative tool. So let's now take control of one of these avatars. As you see, I've now got control of it, and I'm now using the menu that's attached to the controllers on my hands to control things and move objects around and such. So I've now moved location, and we're now crouched under the wing. I'm going to stand up and enter the wing with a drill in my hand to check I have enough space for the user to use the tool in here. And now you can instantly see how we can now relate the size of what we're seeing here back to a real object. One of the things you may already have noticed, obviously this may cause some problems for using that drill in here, but also what we've got here doesn't look realistic. We haven't applied a realistic rendering as you would see in, say, a flight simulator or a VR game. And that's because we're creating a VR environment to assess the engineering aspects here. The money or time spent on realistic rendering would just not be adding value. It'd be like painting the wooden mock-up. If we were preparing the VR scenario for assessing the aesthetics or something really for publicity, then realistic rendering may be applied, but it comes at a cost of performance as well as time. So literally the important thing here is how quickly we could get that CAD data into our VR system. That's one of the key that we've got in our VR systems. So VR system here, we're showing here is an Airbus VR system that we actually created ourselves. To get that CAD model of that wing, so this is a complete wing structure into here. That takes around 13 minutes from hitting the button to be able to call it up into VR. So I think you can appreciate that's fairly quick. And for those of you who are geeky on VR, you'll know that VR is all about number of polygons. There's around 35 million polygons in this model. So this is another example where VR becomes very powerful. So I've already alluded that we've got a 3D CAD system, and we give our designers a 2D display system. Now, typically what we can find is that when they're designing objects, they create a flat 2D plane and work on that plane. And that's okay if we're looking at, say, prismatic machining of these components where it's on a traditional machining. But when we think about things like pipework, where we might want to curve it around components, that can be quite difficult in CAD. So we can actually now create pipes in our VR environment. And let's just run the video to show you this. So we're going to create a hydraulic pipe harness, or this could be an electrical pipe, running around in VR and create some points with that. And we can put kinks and bends in this pipe to run it wherever we want. Now, obviously, to do that in CAD can be very complex. So this makes it a lot easier. And what we can do once we've created this geometry in our VR system is take that back into our CAD system and then refine it in our CAD system to create all our manufacturing data. This is a final example of what we're going to show you or what we can do in VR. So obviously grab objects and move them around. So this could be for assembly or repair. So in this, I'm going to grab an object and move it around. Now, just using it in VR like this with the controller does have limited on how realistic it feels. So what we can do also is take one of the real objects and put tracking markers on it, or 3D print an object and put tracking markers on it. So there's an element of realism for it. A good example of that is we had a jig assessment to do where the jig was on a platform several meters up in the air, and the operator was holding a large torque wrench at arm's length on the wing. Now, using one of the fly sticks or the controllers for VR, you could probably stand like that all day and look down, there's no problem. When we actually tracked up a real object that's quite heavy, holding it at arm's length, several meters up on a jig and looking down, actually that wasn't very comfortable at all. So it's actually bringing out some of those ergonomic aspects. So sometimes VR alone doesn't solve our problems. So hopefully that's given you a bit of an insight into VR. And now let's move on to something different. Even though we have VR, there still may be a need for physical mock-up. And I'll explain that with an example of the A380 transportation checks. So when we're looking at industrializing the A380 aircraft, we need to check that we could drive those large assemblies from the port to a final assembly line without hitting bridges or road signs. And just to put it in perspective, in the picture I stood up in the wing, I was about here. So obviously we don't want to be hitting any objects, particularly as that's a high precision, high cost item. So we need to transport that safely. So we built a wooden mock-up to test the route for clearances before we industrialized the aircraft. So this is the A380 transportation mock-up. It made 3 checks together. So we've got the fuselage and the port and starboard wings. You'll notice that only the critical edges were modelled on this mock-up. So it's only those bits were likely to hit something. With modern large-scale 3D scanning, this may be possible to do today in VR if we scanned the entire route, but I suspect with the effort needed and the size of data that if we need to do such a check today, a wooden mock-up would still be the quickest and cheapest solution and the one we'd have most confidence in. That's a little bit about VR. I'm now going to ensure you're familiar with 3D CAD, which you've already mentioned, but you might be surprised at some of the other technologies that we use for visualization, and they might actually appear a bit primitive. We use panoramic photography in a similar manner to Google Street View to give a realistic image of the wing. This is a panoramic image, and it's viewed as a flat image here, which has a field of view 360 degrees wide by 180 degrees high. I'll come back to this image in a moment. Using commercial software that's COTS, we combine the images together to build a tour, typically inserting hotspots and links between the images, which may also include panoramic digital images from our CAD system. This can become quite complex. The example here has nearly 600 images, over 3,500 hotspots, and over 2,600 links. All these form an individual wing tour. Unfortunately, I'm not able to show you a complete one of these tours for IP reasons in this medium. But this is one example I can show you. Obviously, that's not an Airbus wing, and it's a fuselage of a Bolingbroke aircraft. So again, this is part of the Bristol Aero Collection Trust. It's currently being worked on a conservation hangar, so this may be on display in the future. This video allows me to initially show you the concept of panoramic photography. So you can see it gives a very realistic view, and the benefit of this is that it's available to everyone via desktop. So we don't need any VR system, and we don't need any CAD system. Now, literally, it's a web browser. It's also easy to navigate. People are familiar with navigating around Google Street View. So in addition to what we've got here, our production version would have hotspots on to navigate around the wing, along with a map to show us exactly where we are and in what direction we're facing. And coming back to the image I showed you a couple of slides ago, this is that same image viewed as a panoramic. Obviously, I've captured it as a video rather than a panoramic tour here, so there is a drop in quality. If you remember this from a static viewpoint, this gives, oops, let's come back a moment. Okay, from a static viewpoint, you can see that we can essentially move around the wing. Normally, this will be controlled by your mouse. So remember the point we spoke about earlier about the dangers of going into a wing. This allows employees to look inside the wing without actually going into it. So the benefit of that is it avoids any disruption to production. It avoids any risks of FOD. And it avoids any need to have everyone specially trained to go in there. It also means that this can be available to people who are claustrophobic and not willing to go into those confined spaces. It's actually for a wing space, this is actually quite a large space in here. There's some spaces a lot smaller. Okay, that's it for what we're going to cover on VR and panoramic visualization. What I do is ask Francesca and Ben just to talk about the training programs they're on, just for those of you as students to see the typical things that are available at Airbus as career opportunities.
Okay, so we did the commercial scheme, but the defence and space scheme is fairly similar to what we've done. So it's a 2-year programme consisting of focus training and sort of various different placements around different areas to give you an insight into the sort of the business as a whole, as I mentioned earlier. So it's a £27 salary with a welcome bonus, and then you get 25 days holiday and some additional days to be taken flexibly. And then, yes, there's various different opportunities in different areas. You get lots of development and plenty of support and access to so much more opportunities and variety of things you can sort of be interested in and tailor it to how you want to. So I believe applications have now closed, but if you go to our Airbus website, then you can see what is available. So Ben, if you want to carry on.
Yeah, thanks, Fran. So I did a placement as part of my degree at Airbus, and it's called an internship. At Airbus, they only offer a 12-month duration because it takes about 3 months just to understand what's going on and get your head around some of the more complex issues at Airbus. So they did offer the 12-month one. On the 12-month scheme, you're generally exposed to quite a lot because you're in one department. You get to meet lots of people in your department, and you can understand a lot about what happens in their different roles and everything else. It's generally a paid internship, so it's not like some of the other ones you see around online. It's about £18,000 a year, and you get the same holiday entitlement as everyone else. And generally, depending on which part of the organisation you work for, you get to work more or less same hours as everyone else, which is flexi. So generally, I'm in the office from 8 till 4 or 8 till 5, depending on what I need to do. And then on a Friday, we generally have a half day. So it's quite nice to sort of get into the swing of things if it's your first job, because it's not all high pressure. It's quite nice. They do give you a reasonable level of responsibility, and you are expected to do things while you're there, but it's definitely worth the opportunity if you want to do it. Again, like Fran said, if you want to have a look at any of the opportunities that Airbus have as an early careers right now, the best thing to look at is the website. I guess it's open to any questions now on any of the topics.
Yeah, if we just add one thing on the internship, so the year in industry. Normally during that, if you like Airbus and Airbus likes you, that does then create a short interview stage for getting onto the graduate program. So it can be a good way to sort of try before you buy into your career, but also then see just how many different roles are available in Airbus. Because obviously in a large company, there's roles even within IT that you probably didn't even realise existed. Yeah, things like managing obsolescence of software, that type of thing. Some people, unless you've actually seen it, there's no comprehension to it. Okay, so I guess we'll open up for any questions.
Thank you. That was a really interesting talk. My name's Pip and I'm on the committee, and I've seen a question come in here from Gary. And the question is around, do you have any figures for the scale of the savings that have been made using these techniques compared to the historical methods?
Savings on these, that's always a challenge for us. And generally what we find is the way Airbus works, no one really wants to commit to that. But certainly to justify the business case for a VR suite runs into at least 100,000 euros, and we could justify that over 2 or 3 years. So we're looking at that. But generally, it's a little bit swings and roundabouts, and it's very, very difficult for us to do. It's something we're struggling with. On the panoramic side, the business case alone for one wing tour, that was based on 6 months, reducing the amount of engineers traveling up to Broughton just to go and have a look inside a wing. So originally what the design team for that came to us to say, we want a indexing system so we can store all our photos on it. And we just said, no, you don't. You want a good set of photographs that are all indexed and controlled that you can do. And we showed them that. And then we've done nearly every Airbus aircraft wing as the family wings so far. But yeah, business cases are probably one of the most challenging aspects of our job.
Is there any plans to develop the use of VR in future? For example, in terms of linking it to robotics and doing jobs in small spaces that are traditionally hard to get to? Yeah,
we've just essentially released our first version of our new VR system. So it's our second generation VR system. We've just locked it off, and that's going into its second stage. So our VR system, our internal VR system, is being managed through scaled agile. So it's got all the sprints, so constantly being assessed and enhanced. There's a number of things on those, but probably I can't talk to you on those without getting prior permission for them. But if you think about the topics that are coming up in the general engineering world about digital twin and those aspects, then you can see exactly sort of the type of things that we're looking at.
Just a question from me. If you were a secondary school student, perhaps in A-level, what sort of things, work experience, would you start to think about doing if you wanted to apply eventually for an apprenticeship at Airbus?
Certainly, we normally do work experience, and what we try and do for the work experience is let you come in and have a look and just see just what different careers are in Airbus. So there's a general concept in people that engineering firms are knee-deep in swarf in a dirty, oily workshop. But if I showed you a picture of one of our manufacturing areas, it's more like a hospital operating room. It's that clean, but also the amount of technical roles supporting that. So give them a complete flavour of, if you wanted to do things where you spent all day performing mathematical calculations, yep, there's roles that will do that. If you want to spend all day doing 3D designs on a CAD system, yeah, there's lots of roles with that. So it's really to give them a broad scope to understand just what they can do. So it's normally a week's work experience, and as part of that was tied in with getting your Silver Industrial Cadets Award. So something that you can actually take away from that as well. And generally, we get a lot of positive feedback from the work experience. Obviously, this year it all stopped, and we're looking at how we can do that next year. But in addition to the formal work experience, we also have school visits, and that could be a site tour, that could be a tour of the VR suite. Would support those, or come and give individual talks on, say, how aircraft fly or VR to those individual schools.
Ryan's asking if you are able to measure the increase in safety from the use of VR.
Again, it's difficult to quantify, but some of the aspects that we've done recently, where they've looked at on the ergonomic side, we've got a number of applications that look at the stresses on joints. So you're looking at actually, are you holding that position too long? Is that tool too heavy in there? And one of the tools that we used was a VR system called RIA, which is realistic human ergonomic analysis. So we've done a lot of qualification on more detailed analysis of ergonomics. It's a topic that is always coming up. But also what it allows you to do beyond just your basic ergonomics is then start to look at different populations and distribution of avatar sizes. So that's where it starts to have benefits. You're much more confident in what you've done.
So the VR technology that you demonstrated earlier in the talk, you were clearly using that from home. Has the internet-based collaboration and the use of VR been helpful during the last number of months, given the intensity of home working that's happened? It's
interesting. It's starting to pick up. So originally, okay, yes, we had our VR suites with HMDs, and as you can imagine, we don't want too many people in there sharing glasses or head-mounted displays. So there's been a bit of a lull. But what we're seeing now is a big pickup and a lot of demand. So literally, I've spent a number of days now working with a number of engineering teams who are interested in now picking up and ramping up their use of this technology. That's for a number of reasons. One is because actually, yes, we can do VR from home now. So we could do a collaborative design review with people working from home. That's one aspect. There's obviously, they can't use our main VR suites. So it's that. Also just access to the data. So one of the big use cases of VR, which we see from our defence space team, but also in our Filton VR suite, is one we didn't see coming, is VR allows you to navigate around that 3D data very, very easy. So what it means is a non-CAD user can come in and they can move around that 3D data and that 3D model much easier than they could in CAD. That's really another use case where it adds a lot of value. So it's opening up that 3D data to beyond the normal audience.
Earlier in the talk, you I don't know if you meant to, you gave an offer to people to come down to Bristol and look at your VR suite. Is that open to schools as well?
Yeah, absolutely. Yeah, we'd encourage schools, and we're just in the process of building a STEM zone. And obviously that got it was within weeks of being finished when obviously COVID hit. But they're hoping to have that up and running by the middle of next year. And ideally, when we can, at the moment it's all stopped. It's one of the first things that was stopped because obviously we don't want any risk to our manufacturing areas. So any slight risk was reduced. But as soon as that started, yeah, we're more than happy to have people start again. We're more than happy to bring people on site and show them the real tools. And actually on site we can show you more because it's a much more controlled environment.
Good. That sounds wonderful. It's a long way to go, but it's probably worth it. So that if there's any last questions, can you make them available in the chat section, please? If there aren't any, well, thank you very much, Ben, Francesca, and Nigel. It's been a very interesting talk. I've really enjoyed it, and I hope everybody else has as well. Just to the members out there, the BCS members out there who are listening, we are going to run after this. After Nigel has gone, we are going to run an AGM. So if you wish to attend the AGM, can you stay on the line? Any last thoughts, Nigel?
No, just I said just appreciate this is one view of the use of VR. So if you go to another company, say Jaguar Land Rover, you'll see a slightly different use. And I'm not going to say they're wrong, and they won't say I'm wrong. It's just different applications of the same use. But also don't look for applying really technical technology if you don't need to, which is why our panoramic side. For those of you students looking at careers, my comment would be, okay, good luck for your forthcoming exams, but also in your career, think about just constantly learning and moving around. One of the things that we recognise in Airbus is that in 5 years' time, you won't be doing the job you join Airbus doing. My career is a good example. The first time I saw VR was around 15 to 20 years ago, and it was powered by 2 Cray computers the size of a mini car. I've now got more power in the laptop at home, so you can see how things move on, and that's only going to change. So roles are changing dramatically. So focus on core skills and flexibility, and just be willing to adapt to the environment around you.
Thank you. So once again, thank you, Francesca, Nigel, and Ben, and hopefully see you soon.
Okay, thanks, Dan. Thanks, everyone.
Thank you very much.
Thanks, guys. Bye.
Bye. So thank you everybody who joined. If you want to stay around for the AGM, we'll be starting in a couple of minutes. Do you want to get the presentation up?
Yes, sure.